Hey guys, it's Adam from Premium Poker Tools, and in this video I'm going to go over pot odds, effective odds, implied odds, and reverse implied odds. So a lot of people have heard of these four things, particularly pot odds, and a lot of people have also heard of implied odds, reverse implied odds, effective odds, um, but a lot of people don't quite understand what these things are. They might know that effective odds takes pot odds like a step further, but they might not quite know what it is, or they might know what it is, but they might be confused about how to do the math to figure it out. So in this video, I'm going to try to clarify all of that, and hopefully by the end of the video, all of these things will be very intuitive to you. So we're going to start off with pot odds, and to understand it, we're going to go through this hand example. So we have pocket kings. The board comes ace, 9, 4, 3, 7. The flop checks, and then villain bets the turn. And then on the river, villain bets $100 into a $100 pot. So we have to decide whether or not to call with our pocket kings on this board where there's an ace. So how do we go about doing that? The way to go about doing that is to kind of break things down into two steps. So step one is how much equity do we need? How much equity do we need? And then step two is going to be how much equity do we have? How much equity do we have? So let's start off with step one. So how do we figure out how much equity we need? The answer to that involves figuring out pot odds. So what are pot odds? So in this spot, the river, it started off at $100. The pot was $100 on the river. And then our opponent bet $100 into the $100 pot. So now we're looking at a $200 pot. And we're sitting here deciding whether or not to call another $100. So our opponent put $100 in. Now it's $200. Now we have to decide whether or not to call $100 in order to win the $200 pot. So the pot odds are the ratio of the pot to what we need to call. So this ratio is 200 to 100. But you'll never hear people really talk about 200 to 100 pot odds. What we do is we simplify it. So we can say instead of 200 to 100, we can say that the pot odds are 2 to 1. So we've made some progress in answering this question. We figured out what our pot odds are, but we still don't know how much equity we need. So to figure out how much equity we start off with our pot odds, and then we need a formula. So the formula is risk divided by risk plus reward. So here, when we're in this spot, when we're deciding whether or not to call 100, we would be risking 100 in order to win 200. So we're risking, this is what we need to risk, and the reward, if we win the pot, would be this 200. So we can take that and plug it in here. But the thing is, when we look at it in terms of pot odds, instead of thinking we're risking 100 to win 200, we can think we're risking 1 to win 2. So it's a little bit more simple that way. So we can say we're risking 1 to win to win 1 to win 2, and we plug this into the formula, and we get 1/3, or about 33%. Cool. So now we've answered this first question. How much equity do we need? What we did, just to kind of recap, is we looked at what our pot odds are, and then we used this risk divided by risk plus reward formula to see how much equity we need. So, if the pot odds, instead of 2 to 1, if they were 3 to 2, now we'd be risking 2 to win 3. So we'd have 2 divided by 2 plus 3 equals 2 over 5 equals 40%. So no matter what the pot odds are, you can put them into this formula to figure out how much equity you need. And I'm going to give you some kind of common values. So if we have 2 to 1, we need 33% like we saw. If we have 3 to 2, we need 40%. If we have 1 to 1, we need 50%. And let's go to the left a little bit. If we have 3 to 1, we need 25%. And we can even go one more. Let's just say, so 4 to 1, we need 20%. So a lot of poker players kind of have these values memorized. So, they're not actually thinking about this formula while they're playing at the tables, really. They kind of have these numbers memorized. And what you can do, so like, let's say the pot was 202, and we need to call, 104. So now this doesn't actually reduce to 2 to 1. But what we can do is we can approximate. So we can say which value of these pot odds is closest to what I have. And this is pretty damn close to 2 to 1. So we can just say this is 2 to 1. But if we had, maybe like 220 to 104, now, it's pretty close to 2 to 1, but it's like a little bit towards 3 to 1. So we can say maybe instead of 33%, maybe it's 31% or something like that. So we can kind of use these like simple numbers as our baseline, and then we can kind of adjust a little bit after that. So we've been talking about question number 1, how much equity do we need? Then, of course, we have the question of how much equity do we actually have? And, that's a great question, but that's a little bit beyond the scope of this video. This video, I'm more addressing the first question. So I'm going to leave, figuring out, do we have enough equity in this spot? We have pocket kings. They bet $100 on the river. Are we beating enough hands? Is our opponent bluffing with, something like Queen Jack? Are they going to be betting a 10-9 for value? Are they going to be betting pocket queens for value? So we'd have to ask ourselves these questions to see if we have enough equity. But this video is more focused on how much equity do we need. Okay, so that hopefully gave you an understanding of what pot odds are. And I just want to go through one more pot odds example. So we have pocket jacks. We raised $10 pre-flop, and then a short stacked opponent shoves $50. Everyone folds to us, and we have to decide whether to call. So how often do we need to win? How much equity do we need here? So let's see. So we put in $10 into the pot. Our opponent put in $50 into the pot. And let's just assume that the blinds get like raked away. So now we need to put in 40 more. So the pot now is $60, and we need to call another 40. So how much equity do we need here? Well, the pot odds are 60 to 40. This can be reduced 6 to 4, 3 to 2. And then we plug this in, so we're risking 2 to win 3. So 2 divided by 2 plus 3 equals 2 over 5, and that's 40%. So we saw this ratio before. In this spot, we would need about 40% equity to justify calling. And, we're not going to talk about whether we have it, but just kind of briefly, if they're only shoving queens plus and maybe ace king, we probably, well, ace king maybe, but if they're only shoving queens plus, like, we obviously don't have enough equity. If they throw in pocket tens and pocket nines, then we're getting there. So those are the kind of questions we need to ask to see whether or not we have enough equity. So this has been 2 examples of pot odds. But now I want to go through an example that is going to show you that pot odds are a limited way to think about poker. And this example is going to get into all of the other things. It's going to get into implied odds, effective odds, and reverse implied odds. So here we have 10 of hearts, 9 of hearts. The board comes ace of hearts, 7 of hearts, 2 of spades. Our opponent bets $4 into $8 on the flop. Do we call? So let's see what would happen if we looked at this in terms of regular pot odds. So the pot is $8, and then our opponent throws another 4 in there. So now the pot is 12, and we need to call 4. So the pot odds here are 3 to 1. And we've seen we can plug this into the formula. 1 divided by 1 plus 3 is 1/4. So here we would need 25% equity to justify calling. Okay, so now we figured out how much equity we need. How do we figure out how much equity we actually have? So here we have a flush draw, and let's make a couple kind of questionable assumptions. Let's assume that when he bets, we know that they have an ace. We know we're behind. And let's assume that there's no other way for us to win other than hitting our flush. We can't get a runner like 10-9. We're not going to hit our backdoor straight draw. We're just going to keep things simple and assume that the only way for us to win the pot is to hit a flush. So with that, we can use something called the rule of 4 and 2. The rule of 4 and 2. And this rule says that you take the number of outs and when you have 2 streets left, we multiply by 4. And if there's only 1 street, we multiply by 2. And that's going to give us our equity. So here we're on the flop. We get to see 2 more streets. So we're going to be multiplying by 4. And we have 9 outs with our flush draw. So we can say that 9 times 4 equals 36. And what that means is we have approximately 36% equity, according to the rule of 4 and 2. And this isn't exactly right. It's going to be close. It's going to be maybe off by 1 or 2%. But the rule of 4 and 2 is a really easy way to kind of approximate your equity. Okay, so we have 36% equity. Let's say we have 36% equity. Our pot odds told us that we only need 25% equity. But the rule of 4 and 2 said that we have 36% equity. So it's looking like it's an easy call. Okay, so if you've played poker for some time, if you've got some experience, maybe you can see some problems with this sort of thinking. So here we're we're saying that we're gonna see 2 more streets, but as you know, when our opponent bets the flop, oftentimes they're gonna follow up with a bet on the turn. So in order to see both of these streets, we're gonna have to pay more money on the turn. So we can't just say that we have, we're risking 4 to win 12. We really have to say that we're risking, like, I don't know, more money to win 12 because we're going to have to pay more on the turn. So what do we do about this? Well, maybe we want to say, okay, let's just ignore the 2 streets. Let's say that we can only see 1 street. So we multiply 9 by 2 and get 18. And now that's less than what we need. But that's not a great approach either, because on the turn with our flush draw, we're probably going to want to call. So what do we do here? What we do is we have to look at something called effective odds. We have to look at our effective odds. So what does that mean? When we look at our effective odds, we want to ask ourselves, how much money do we really need to put in order to, get to showdown? So, like I said before, we're not really putting in 4 to win 12. We're going to have to put in more money on the turn. So when we ask ourselves, how much do we lose when we miss? It's going to be more than just this 4. So on the turn, when we call the flop, the turn is going to be $16. And let's say that our opponent bets another $8 on the turn. Well, we're going to need to call that $8. So when we lose, when we miss our flush, we're not just losing this $4, we're losing 4 plus 8. So we're losing $12 now. So then we have to ask ourselves, okay, how much do we win when we hit? And, now it's a little bit different. So now we're not just going to win these $12 when we hit. Our opponent put in another 8. So now we're going to win $20. So let's write this down. So one question is, how much do we lose when we miss? How much do we lose when we miss? And then the second question is, how much do we win when we hit? How much do we win when we hit? So here it looks like when we miss, we're paying $4 on the flop and we're paying $8 on the turn. So when we miss, we lose $12. But when we hit, we're not only winning, this $12 on the flop, the initial 8 plus our opponent's 4, we're winning this 12 plus another 8 on the turn. So we can scroll down and say that when we hit, we actually are going to win $20. Okay, so now this is going to give us our effective odds. How much do we win when we hit versus how much do we lose when we miss? So now we can say that our effective odds are 20 to 12. And that's going to reduce, I think 5 to 3. And then if we want to kind of make that, into something to 1, that's going to be 1 2/3 to 1. So these are our effective odds, 1 2/3 to 1. And, if we want to take this and figure out how much equity we need, I'm going to use the 3 and 5. So we're risking 3 and in order to win 5. So we have 3 over 8, and that's going to be 37.5%. So very interesting here. We previously looked at this and said that we have 3 to 1 pot odds, but now we only have 1 2/3 to 1 effective odds. So 3 became 1 2/3. And then also, we said we only need 25% equity to justify calling. Well, now that got bumped up to 37.5. So once we factor in the fact that our opponent is going to bet the turn, things change a lot, right? We estimated that we have 36% equity. When we used the pot odds, that was looking like a clear call. We have a lot more equity than we need. But when we used effective odds, now we're saying that we need 37.5%, and we only have 36%. So now it's looking like we should fold. So I want to point out that the thing is that pot odds are an approximation. They're not, when you're in a situation like these first two examples, pot odds are actually exactly what you want. And the reason for that is because once you call, the hand is over. Here, we were pre-flop, but once you call, the hand is over because your opponent was all in. And here, maybe you guys aren't all in, but it's over because you're on the river. So when the hand is over after you make your decision, pot odds are exactly what you need. But when you're in a spot like this on the flop, in a very dynamic kind of situation, pot odds are only going to be an approximation. You really can't just use pot odds and assume that it's going to be right. And I think we saw that here, how, the 25% went up to 37.5%. So I want to kind of really make you guys understand that pot odds only apply to situations that, it's an end of action situation. Once you make your decision, the hand is over. In other situations, pot odds, they might be a decent approximation, but you shouldn't really just rely on them. Okay, so with that said, let's kind of return to this spot. So based on the effective odds, it's looking like we need 37.5%. And we only have 36%. So maybe we should be folding. And so I'm going to explain why we shouldn't be folding. So there's something else called implied odds. So implied odds are going to be the reason why we can justify calling here. So the thing is with implied odds is we're going to assume that, on the flop, it's $12. He bets, we call. The turn, let's say we miss, he bets it again and we call. Let's say that we hit on the river. Well, when we hit on the river, the pot is going to be what, $32. The effective odds calculation, that assumed, if we scroll back down here, how much do we win when we hit? It assumed that we're just going to win, the $20, the 8 plus 8 plus 4. In reality, we can expect, on the river, we can bet and expect to get called sometimes. So instead of saying that when we hit, we only win this $20, we can say on this river, I think we're going to win another $20. We just made a flush, and you know, I think we can win more money. So with implied odds, we're going to change the answer to this question right here. How much do we win when we hit? We're going to say, I think we're going to, when we actually make our hand, I think we're going to win more money. So now, instead of saying that we win 20, now we can say that we win 40 when we hit. So now you can see that that's going to change things a lot. So now we have, once we factor in the implied odds, now we can say we have 40 to 12. So this is going to reduce to, I think, 10 to 3, or we can say 3.5 to 1, or sorry, 3 1/3 to 1. So very interesting. So just to kind of back up a little bit, we started off with 3 to 1 when we just looked at the pot odds. Then we went down to 1 2/3 to 1, and now we're going up to 3 1/3 to 1. So what does that do to our required equity? So let's see. So we're risking 3 to win 10. So 3 plus 3 divided by 3 plus 10, 3 over 13. Let's plug that into the calculator. 3 divided by 13, about 23% equity. So once we factor in our implied odds, we only need about 23% equity. So let's take a look at how our required equity changed. So first we said we needed 25. Then when we factored in effective odds, we said we needed 37.5, so it jumped up. But then when we factor in implied odds, it jumps down to 23%. And if you remember, we have about 36% based on the rule of 4 and 2. So now it's looking like we have a very clear call. We have 36% and we only need 23%. And that's, very close to what I'd say is kind of the final answer. But there's one more thing to think about here, and that's called reverse implied odds. So the thing with reverse implied odds is that when we hit our hands, we don't actually always win. When we hit our hand, we'll have a flush here. But when we make a flush, it's possible that we are going to lose to a better flush. Maybe they have a king high flush. Or maybe, we make our flush, but they make a full house. So when we win, we don't have the absolute nuts. When we hit one of our outs, we're not going to automatically win the pot. Sometimes we're going to think that we win, but we're going to get beat. So that's a little bit complicated to factor in. I'm going to kind of say, like, where was it? So to this question, how much do we win when we hit? When we looked at the implied odds, we said we're going to win another $20 on the river. But So in order to factor in reverse implied odds, I'm going to kind of eyeball it and say, instead of expecting to win 20, we're going to say I expect to win 16, a little bit less. Sometimes we're going to win 20, sometimes we're going to lose 30. More often than not, we're going to be winning money. So I'm going to say, on average, we're going to win about 16. So now we change our answer. How much do we win when we hit? So previously we said the 12 plus the 8 is 20. And then with implied odds, we added another 20 to say 40. So now instead of adding another 20, we're going to add another 16 and say that when we hit, we're going to win 16. When we hit, we win another 16. Not 20. Okay, so now we again, this should be 36. We're gonna win another 16, not 20. So in total, we're gonna win 36 when we hit instead of 40. Okay, so now we have an answer to the question. When we hit, how much do we win in total? That's going to be 36. And then the answer to the question of when we miss, how much do we lose? It's going to be the same thing. We're investing 4 on the flop and then 8 on the turn. And we're not going to invest anything on the river because when we miss, we lose. So that's going to be the same thing. When we miss, we're going to lose 12. Okay, so now this reduces to 3 to 1. And how funny is that? That's exactly what we started with the pot odds. And that's going to mean that we need 25% equity. So just to show you, we started off with 3 to 1 pot odds, 12 to 4. And after going through this whole big process, it started off at 3 to 1, then it went 1 2/3 to 1, then it went up to 3 1/3 to 1, and then it went back down to 3 to 1. So here we have 36% equity, and after doing all of this analysis, we came up with a number that we need 25% equity. So it's looking like we have a pretty easy call on the flop, even if we know that our opponent has an ace. So that's been an explanation of all of these ideas, effective odds, implied odds, reverse implied odds, and I know that after, maybe you're tempted after going through all of this math, you're thinking to yourself, hey, Adam, we started off with 3 to 1 pot odds, and after factoring in all of these things, we ended up with 3 to 1 odds. So why go through it? Why not just use pot odds as an approximation? We're just going to end up at the same place we started. And in this example, that ended up happening. We ended up at the same place we started, but that's not always going to be the case. Sometimes you're going to have more implied odds. Sometimes you're going to have less implied odds. You don't think you're going to get paid off on the river. Sometimes you think that, on the turn, they're going to check a lot. So when you ask the question of how much do we lose when we miss, well, if our opponent is going to check the turn a lot, maybe we're not going to have to pay to see the river. So, in this example, it ended up working out kind of back to where we started, but that's not necessarily going to happen. And we can call this the real odds. The real odds can, very much be very different from the pot odds. So I definitely wouldn't say to just use pot odds and assume that all of this stuff is going to balance each other out. I would really encourage you to go through all of this and calculate your real odds. And you know, in this, like, this video is just, I don't know how long it is, however long it is. But anyway, if you want to kind of go through things in more depth, the book The Theory of Poker by David Sklansky, he talks about all of this in chapters 5 through 7. So chapter 5 starts at pot odds. I'm going to go to the table of contents. Yeah, so chapter 5 talks a lot about pot odds. Chapter 6 talks about effective odds, and then chapter 7 talks about implied and reverse implied odds. So if you want to kind of, dive into this in a little bit more depth, I would encourage you to check out his book. So finally, to end the video, I want to mention that this looked like we did a lot of math, and we did do a lot of math, but even by doing all of this, this is still an approximation. I'm going to write that down. Still an approximation. This did not give us an exact answer to the question of how much equity we need. It's not exact. And I'll explain why. So, there's going to be some turn cards that we might want to bluff on. We might have fold equity on the turn. We might want to check raise. So, this analysis right here, it did not incorporate that at all. The fact that we might have fold equity on the turn. It didn't incorporate that we might find a good spot on the river to bluff. And it also, I just eyeballed all these numbers. I really did. We just, he did bet 4 on the flop, but I don't know how much he's going to bet on the turn. I don't know whether he's going to check the turn. I eyeballed these numbers. I made them up. In reality, let's say the flop comes, we can call, fold, or raise. We call the flop, and then the turn comes. There's a million possibilities. He could bet half pot. He could bet 3/4 pot. He could bet full pot. He could check. He can overbet. There's many possibilities. And if we were to really answer the question of how much equity we need, we would need to do a more thorough analysis where we look at all of these possible branches on the tree. And I did a video of expected value. If you're interested in that, I would encourage you to watch the expected value video. I'll post a link in the description. But yeah, I want to emphasize that I made these numbers up. I didn't pick them out of thin air. I think I kind of used my judgment to come up with a good approximation, but I did make them up. And so the fact that I made them up, how much is he going to bet on the turn? How much are we going to win when we hit on the river? How much should we reduce it based on the reverse implied odds? I made these numbers up, so it looks like a lot of math and a lot of thorough analysis, but it's not exact. However, with that said, it's an approximation. It's not exact, but it's still pretty good. Still pretty good. And the thing, with poker, there's kind of if we draw a little balance beam, there's a trade-off with kind of precision and effort. If you want to apply more effort, you're going to get more precision. So maybe it's not this is maybe not a good metaphor, but I think you get what I'm saying. If you take more time to calculate things exactly, you'll get a more precise answer. But you have to ask yourselves, is that added effort, is that added precision worth the effort? So if you really did a full, expected value tree, you might figure out that instead of, what did we come up with? Instead of 25%, maybe it's 23.7%. You know, was that little change in a percentage worth the effort? And I'm not going to answer that for you. I think it depends on the situation, um, but that's kind of what you have to think about. And so by doing all of this, implied odds, effective odds, all of that, um, it's pretty good. It's not perfect. I want to be clear that this isn't exact, but it's pretty good. So anyway, hopefully after going through all of this, we have an understanding of pod odds, implied odds, effective odds, all this stuff. And hopefully you can use this to study and kind of improve your game. So again, this has been Adam. I'm the founder of Premium Poker Tools. Thank you guys for watching.